Hi everyone, this time we're going to talk about what is heat. Now, this has been a question that's been asked for hundreds and hundreds of years, and for a long time people pondered a whole bunch of different ideas. For many years it was believed that heat was stuff, that heat was actually a thing that you could physically weigh or measure. And they thought it was a fluid because they knew heat went into and out of substances, sort of like water goes into and out of a sink. So they called it a fluid, and they named that fluid caloric. Now, there were a lot of experiments that were done to try and measure the quantity of caloric that actually were in substances. For example, they would take a metal object and they would find its mass, and then they would heat it and find its mass. And the idea was that the difference between the two masses would be equal to the calories or the caloric that was left over, the extra heat that one object had versus the other. What they found was they couldn't find it. So the conclusion was either that heat had no mass, or that it was so subtle that it could not be measured. So lots of experiments along the way of trying to determine just what exactly heat is. Today, this is the modern definition of heat. Heat is defined as the total internal kinetic energy and potential energy of the molecules in a substance. So when we say the internal energy or the total internal kinetic and potential energy inside of a substance, what are we talking about? Well, you know kinetic energy. You know kinetic energy has to do with particles racing around that have some sort of speed. And you know potential energy has to do with how far apart molecules are. So when we talk about the amount of heat that is inside of something, we will get to the math a little bit later down the road, but it actually depends upon a whole bunch of things. The mass, how many molecules you've got, a lot or a little. The temperature, how fast or speedy or energetic, how much kinetic energy do these individual molecules have. The type of molecules. Some molecules hold heat very well, some of them don't, are not good heat holders. And the potential energy is the distance between those molecules. Well, what do I mean about internal potential energy? We'll get to that later down the road as well, but we're talking about the difference between a solid, a liquid, and a gas. There is a lot of difference in distance in the molecules between a gas and molecules in a solid, very, very close. So there's a lot of parts and pieces that go into heat. Another definition of heat is this. Heat is defined as the amount of energy transferred due to temperature differences. So if you have two objects, one that is hot and one that is cold, and you put them next to each other, the kind of energy that flows between them we define as heat. Now, that might sound a little bit not very fancy, but it's because heat is a kind of mysterious thing. It involves all of the things we talked about: mass, number of molecules, type of molecules, their speed, their distance. The thing I want you to remember is heat flows. Heat flows from hot objects to cold objects. Heat is this energy that is always in motion from hot to cold. The units we use for heat and internal energy are energy units, and we've talked about these before. So we have joules, calories, kilocalories, which are our old friend food calories, and BTUs. The calorie, if you've had some chemistry in the past, the calorie is defined as the amount of energy needed to warm 1 gram of water 1 degree Celsius hotter. Well, 1 gram of water is approximately the amount of water that you're going to put into a thimble. That is about 1 milliliter of water. And 1 degree Celsius hotter, that is going to be defined as 1 calorie of heat, which is 4.184 joules of heat. If you recall from when we talked about energy. A kilocalorie is a food calorie, and food calories there are over 4,000 joules that make up one food or kilocalorie. Now, where did the unit joule come from? It is a gentleman's name. This gentleman was named James Prescott Joule, and it is pronounced Joule, like jewelry, even though it is got a different spelling. 1 joule is equal to a Newton meter, or a kilogram meter squared per second squared. And back when we talked about work is force times displacement, Newton meters, and that's where that unit comes from. But why did this fellow, James Prescott Joule, why did he get a unit named after him? Well, back in the 1860s, James Prescott Joule and his family ran a brewery. They actually made beer. And while they were actually waiting for the little yeast to ferment and make beer, he did some experiments down in his basement. So he was a scientist. And the reason why he is very famous is he demonstrated that mechanical or kinetic energy could be transformed into heat. He proved the law of conservation of energy actually included heat as a type of energy. Remember what we said earlier, that for a long time people thought heat was this fluid, caloric, and Joule proved that no, it's not. It's just another form of energy. The experimental setup that Joule used looked something like this. He had an insulated container. In my mind, I always think about one of those containers you make ice cream in, and it had paddles inside. On the top of it, there was a spool that had some thread or string attached. This would be attached to a weight, and when the weight would fall, it would make the whole rig spin, and the spinning paddles would actually warm the water. Well, Joule repeated this experiment over and over and over and over and over. And as the weight fell, the potential energy could be converted into kinetic energy. And so he knew exactly how much energy he put into the system. And he could then, using a thermometer, really carefully analyze how much heat got added to the water in the system. By repeating this over and over, different amounts of water, different amounts of weight, he proved that the amount of weight here that he added was directly related to the amount of heat increase there, thus proving that law of conservation of energy also included heat. Now, another unit of heat is called the British thermal unit, also abbreviated BTU. It's very similar to a calorie. The definition of a BTU, it's the amount of heat needed to raise the temperature of 1 whole pound of water by 1 degree Fahrenheit. So where are you going to see the BTU? You're going to see it on water heaters, boilers, things like that. Very large heating kind of appliances in the United States. When we're using the English system of measure, you will periodically see BTUs. All right, ladies and gents, that is that for this time, and we will come back later. See you at that time. Bye-bye.